So, what actually makes a piece of software good code? I mean, we all know it has to work, right? But is that really enough? Today, we're going to dive into what truly defines quality code, all the way from the super strict rules set by regulators down to the gritty, real world question of who has to fix it at 3 in the morning. Let's dig in. So, first up, we're going to look at the rules that build digital trust. Then we'll see how to move past just reacting to those rules. From there, we'll get into how you can actually measure quality, hear from the folks working in the trenches, and finally, wrap it all up with a simple test to see if your code is truly human-proof. All right, let's start at the very top. We're talking government mandates. Now I know, this might sound a little abstract, but stick with me, because in highly regulated fields like clinical research, the quality of your code isn't just some technical detail. It's literally a matter of public safety. And this right here is the core question. As everything shifted from paper to pixels, regulators had to figure out a way to make sure that digital data has the same level of integrity, the same authenticity as a physical document with an ink signature on it. How do you prove, beyond a doubt, that a digital file hasn't been messed with? Well, the FDA came up with an answer. It's a regulation called 21 CFR Part 11. That's just a fancy way of saying Title 21 of the Code of Federal Regulations. But its entire purpose is simple: to lay out the ground rules so that electronic records are just as accurate, authentic, and reliable as the old paper ones. In their world, this is the baseline, the absolute minimum for what they consider good. So, how do they enforce this? The main tool is something called an audit trail. Honestly, the best way to think of it is like a digital detective. It's this secure, automatic log that you just can't mess with, and it records every single thing that happens to a file. It answers those three crucial questions: who made a change, what exactly did they change, and when, down to the second, did they do it? And you better believe that failing to meet these standards is not just a little slap on the wrist. No, we're talking about really serious consequences. Things like FDA warning letters, massive fines, critical delays in getting life-saving drugs approved, and a total loss of trust from the people who are funding the research. This isn't just about writing code, it's about credibility. Okay, so knowing the rules is one thing, but just reacting to them when an audit comes up, that's the old way of doing things. And frankly, it's a super risky strategy. The modern, and much smarter, approach is all about getting ahead of the problem, moving from being reactive to being proactive. And you can really see the difference here. The old way, that's just putting out fires, right? It's manual logs, it's finding mistakes when the auditor is already knocking on your door, that whole stressful, last-minute scramble to get your documentation in order. But the new way, it's all about being proactive. It uses automated real-time monitoring that flags an issue the second it happens. This means you have a much stronger chain of custody, and you're always ready for an audit. It's a total shift from fear to confidence. And this brings us to a really critical turning point. Okay, great. Your process is compliant. Your records are totally secure. You can pass an audit with flying colors. But does any of that mean the code itself, the actual logic, the structure, the design, is any good? See, compliance is just the floor. It's not the ceiling. Right. So if just being compliant isn't the whole story, then how do we figure out if code is any good? Well, that's where we get into the world of software metrics, where the goal is to turn these abstract ideas like good design into cold, hard numbers. And the idea behind this is actually pretty simple, but it's super powerful. Instead of just relying on a developer's gut feeling or their personal opinion, software metrics give us objective, numerical values that actually represent specific qualities of the code. So here's how this actually works. You take a big, high-level goal, something like maintainability, and you translate it into things you can actually measure. For instance, you can measure code complexity, or the size of a piece of code, or even the percentage of comments. And just like that, a fuzzy concept becomes something you can actually track, you can compare, and, most importantly, you can improve. Okay, but here's the thing. You can have all the rules and all the fancy metrics in the world, but none of it matters if the code isn't usable by the people who have to keep the machines running on the factory floor. This is where the human element comes storming in. This quote, man, it just nails it. It gets right to the heart of the whole debate. It's not about what's fastest or most efficient for the programmer to write. It's about what's most effective for the technician to figure out when a production line goes down and every single second is costing the company money. So let's look at the two sides of this coin. On one hand, you have ladder logic. It's very visual. It literally looks like an electrical schematic, which is exactly what maintenance technicians are trained to read. It's super intuitive for them to trace a problem live. On the other hand, you've got structured text. Now, this looks a lot more like traditional computer code. It's way more powerful for complex math and data handling, so programmers love it. But for a technician on the floor, it can be a complete black box. And this means the whole definition of good code completely flips depending on who you ask. The most elegant, most efficient code in the world is actually bad code if the person whose job it is to maintain it can't understand it when they're under pressure. All right, let's pull all of this together, shall we? We've talked about the rules, the metrics, and the people. Let's see how they fit into one single framework for what makes code truly great. And this right here is the bottom line. This quote says everything you need to know. In the real world of industrial automation, the ultimate measure of code quality isn't how elegant it is or how clever the programmer was. It's how much money the business loses when things go wrong. Good code minimizes downtime, period. So here it is, the 3 layers of quality code. First, it's got to be compliant. It has to meet those external rules and build that regulatory trust. Second, its quality needs to be measurable, tracked with objective data, not just gut feelings. And third, and this is arguably the most important one, it must be maintainable by the actual people who have to support it in the real world, especially when things get stressful. So I'll just leave you with this final thought. It's easy to write code that just works, for now. But building code that's compliant, that's measurable, and that's maintainable for the long haul, that's how you write code that's truly built to last. So, is yours?